Alright, who's ready for round 2 of adding and subtracting fractions with common denominators? So now we're shifting gears to example 2. So again, if you thought you understood example 1, I highly encourage that you try example 2 on your own. So go ahead and pause the video and fast forward to the end and see if you get the right answer. Otherwise, follow along with Miss Long. So, sorry my voice. Again, we factor only the denominators. Don't touch the numerators when we add or subtract. I know when we multiply and divide we do, but when we add and subtract you only factor the denominator. So looking here in each of my denominators, which are the same thing since we have common denominators, I have 2 terms and I'm adding, which the only factoring technique we've talked about with 2 terms and involve adding are a sum of cubes. Okay, there's no such thing as a sum of squares. Does not exist. Even if the demon cats whisper in your ear that exists, it does not. It's all a plot for them to attack you. So watch out. Okay, so let's see here. If I have 2 terms and I'm adding, let's try a sum of cubes. So a sum of cubes, we have to be able to cube root each term, which I can't cube root a squared term because I can't divide 2 by 3. And I can't cube root a 2 because there aren't 3 of the same number that multiply to be 2. So guess what, you guys? This is good news because we can't factor this. It's already factored. So yay, step 1 is donezo. I also need to make sure the first term, again, if it's in standard form, is positive, which all my first terms are positive, so I'm good to go. Okay, ignore this minus sign for now. I know you're like, Miss Long, minus 4x. This minus sign is actually not attached to that 4x, so you just need to ignore it for right now. So all of my first terms in standard form are positive, so yeah, we're donezo at that step. This has come up with a common denominator, but guess what? They already are common denominators, so that step's donezo. Step 3, determine where the expression is undefined. So we set every single factor in the common denominator not equal to 0, which I already have a common denominator and I only have 1 factor in each denominator. So I'm just going to set x squared plus 2 not equal to 0. And we're going to solve this thing. Okay, so we never want this to go to 0 or a cat will die. Okay, so we're saving it right now. Okay, so the way I bring positive 2 to the other side is by subtracting that thing on both sides. Bam and bam. 2 minus 2 cancels out and turns to 0, and 0 minus 2 is negative 2. Okay, so we have x squared cannot equal negative 2. Okay, so the way that we undo a squared is by square rooting that thing. So I'm going to square root both sides. Okay, which the square root will cancel out the squared. Bam. So we're left with x cannot equal plus or minus. Okay, because whenever we square root both sides of an equation, a plus or minus will always pop up. Okay, and then let's see here. I have a negative under my square root, so an I is going to hop out. And all I'm left with is root 2, which I can't really simplify root 2. Okay, there's nothing to the same number will multiply to ever be 2. So this would be where the function is undefined. It's only undefined at an imaginary number, which typically we don't get those when we solve, but just in case, I have us covered. So this is where our function is undefined. Okay, so again, it just tells us what values will not work, so we will not kill a kitten. Okay, I'm going to separate these out so we're not confused with the rest of the problem. Alright, so we determine where the expression is undefined. Okay, now it says make all fractions have a common denominator. Well, guess what, you guys? Our denominators are already common, so we don't have to force them to be common denominators yet. Later on, we'll have a fun time doing that. Okay, then it says to add the numerators, but keep the denominators as the common denominator. Also something to keep in mind. When subtracting, distribute a -1 before adding the numerators. Okay, so this is subtracting the entire fraction, not just the 4x. This isn't minus 4x. This is minus the entire fraction. So what I'm going to do is I'm going to put a parenthesis around my numerator because remember, you guys, in front of this there is secretly a -1. So before I combine these, I need to distribute the -1 to both of these terms. Okay, so when we combine numerators, we write it all over one denominator. That is our common denominator. Holy hot dog, right? I'm going to bring down my first numbers, which are 2x minus 1. And then I'm going to distribute my negative 1 to each term. And after that, then I can combine my like terms. Okay, so negative 1 times 4x gives me a negative 4x. And negative 1 times 4 gives me a negative 4. So be careful, you guys. Whenever you subtract two fractions, that negative, there's secretly a negative 1 in front of the entire second numerator. So do not forget to distribute that thing. Okay, it is not just minus 4x. It's minus the whole thing. Okay, guys, so now I'm going to simplify, and if I can, I will factor the numerator. So let's see what happens. All right, let's combine our like terms. So far up top, I have a 2x, and I have a negative 4x, which 2x minus 4x gives me a negative 2x. Okay, and then I have a minus 1 and a negative 4, which negative 1 minus 4 more is negative 5. All snap. All right, let's keep going, All right, and so nothing's left to combine, so it's all over x squared plus 2. And I can't really factor anything out. Again, we usually don't like that first number to be negative. So if you want to, you could factor out a negative 1 in front, which means we're going to divide each of these by negative 1. Okay, so I'm secretly... Remember, guys, we never want that first term to be negative. So I'm secretly going to divide each of these by negative 1 and write what's left over in here. So negative 2x minus 1 is 2x, and negative 5 divided by negative 1 is positive 5. Or the shortcut is write negative 1 out in front and change all the signs. All right, guys, and there's nothing less to do. Okay, usually after we factor, we try to cross out any factors that are in common to simplify this down. Okay, but nothing's here, so that's my final answer. Now, let's say, this is not a part of the problem, but let's say we had like negative 1 times 2x plus 5. Say we factored and we ended up with something like this. Okay, so we factored and we got this. Say that happened. This didn't actually happen, but I just want to prove a point. Okay, if this happens, again, it says to divide out any common factors after you factor the numerator. So if this was the case, I would cross this out, and this would be my final answer. Okay, so that's kind of what we're looking for when we're factoring, to see if we can divide out any common factors and simplify our fraction down. But that didn't happen, so this would be my final answer. Holy hot dog, you guys. And again, ignore this. This didn't happen. I was just kind of proving a point. Isn't it so much fun adding and subtracting fractions? I totally agree with you guys. We're on the same page.